Good morning students, this is Shiba. Now we are going to discuss about the signals and systems, Unit 1 classification of signals and systems. So in our previous session we have discussed about the what is mean by the signals and systems, what are the basic elementary signals available. Now we are going to discuss about the operation of signals. Sometimes a given mathematical function may completely describe a signal, and different operations are also required for different purposes of arbitrary signals. So here comes the different operations that we are using for processing a signal, such as time shifting, time scaling, time inversion or time folding. So what is mean by this time shifting? It is nothing but the original signal x of t is shifted by an amount t naught, which you can clearly see in this diagram given below. X of t is shifted to x of t minus t naught, that is, signal is delayed, and so the shift occurs to the right. If you are shifting x of t plus t naught, then signal gets advanced, and so it is shifted towards the left, which is also clearly depicted in the diagram. Instead of this t naught, you can also select the value like 2, 3, so it will be moving from 2 points or 3 points according to the value you are choosing. Next, time scaling. For the given function x of t, the xa of t is the time scaled version of x of t, and this a is nothing but a into t is nothing but it is the product function. For example, if you are choosing the value of a as 2, x of 2t, and if you are choosing the value of a as 1 by 2, then x of t by 2. So based on this value, either multiplied or reduced according to the value you are choosing. Next, you can see the time scaling function diagram. According to the value of a you are choosing, if it is greater than 1, the compression of signal occurs, and if it is less than 1, then expansion of signal occurs. Here you can also see the example problems. Y of t is equal to x of 2t, so signal gets multiplied by 2, value 2, and t by 3 means how it is reduced. So based on this value, here you can see the example problems, and also amplitude scaling. What is the difference between this time scaling and amplitude scaling? Time is chosen in the x-axis, whereas amplitude depicts the y-axis, and so the value is differed in the y-axis. You can see clearly from the diagram xt, x of t, 2x of t, 0.5 x of t, how it is varied towards y direction. Moving to time reversal, it is nothing but reversal. General meaning, we know that reverse means opposite of something. So it is also called as time folding. In time reversal, the signal is reversed with respect to time, that is y of t is equal to x of minus t, and it is obtained by the given function as follows. You can clearly see the diagram. It is a mirror image. X of t is given as a original image, whereas x of minus t is the mirror image of the original signal. So this is opposite of the original signal. So other functions like addition of signals, multiplication of signals are also available. So these operations are used for adding or multiplication purposes. And also operation of discrete time function like time shifting, scaling, everything is used for real-time implementation of these signals. So based on this topic, you need to clearly know about the time shifting, time scaling, signal addition, multiplication concept very clearly. So problems may be given in this topic, and you need to solve according to the questions they are given. Here I have also given the important links for reference and book reference. Dr. J.S. Chittoor, page number 1-51 to 69 corresponds to the topic which we discuss now. Moving to the classification of signals, one of the major topic in Unit 1, frequently asked question also in part B and C. So what is mean by this classification? How the signals are classified? They are classified major as deterministic random signal, periodic aperiodic signal, even and odd signal, energy and power signal. Deterministic signals are nothing but we can predict the signal, whereas non-deterministic or random signal is we cannot predict how the signal occurs. So that is the major difference. You can see a deterministic continuous signal sine waveform x of t is equal to sine of 3t. It is a continuous signal and so we can predict how it occurs. Whereas the random signal, the best example is noise. We cannot predict how it occurs and how much amount it occurs. So this is the non-deterministic or random signals. Moving to periodic and non-periodic signals. So if given x of t is equal to x of t plus t naught for any integer t, it has to be periodically repeated for every value of t naught. So t naught is the fundamental time period which we are choosing, and its value is equal to 1 by f naught, where f naught is nothing but omega is equal to 2 pi f naught. So for non-periodic, it does not satisfy the condition like x of t is equal to x of t plus t naught. The signal values may get vary. So for a non-periodic signal, the t is equal to infinity and it is not predictable. There are also certain conditions for periodicity to occur, like x of n is equal to x of n plus n in the case of discrete signals, and the value of f naught is equal to k by n. So they also satisfy some properties like sum of periodic signal is also periodic signal. Moving to the even and odd signals, even and odd. Even means it is evenly repeated, and that is it is also said to be the symmetric signal, whereas odd functions are said to be asymmetric signal. So we can find the even and odd part of a function like even part g of t is equal to g of t plus g of minus t divided by 2, whereas for odd part g naught of t is equal to g of t minus of g of minus t divided by 2. A function whose even part is 0 and odd is odd and odd part is 0 is said to be even. There are also various combinations which are given here for different even and odd functions to occur. And also product of even and odd functions are depicted in the diagram. So moving to the discrete time even and odd signals, similar to the continuous signals only, g of n is equal to g of minus n and g of n is equal to minus g of minus n for odd function. Here also for discrete time signal the combinations are depicted. It is similar to the continuous time signals only. The only difference is we will be choosing the sample points of the function. Moving to the energy and power signal, one of the major question repeatedly asked in 2 marks also. Energy signal, a signal with finite energy and zero power, is said to be energy signal. Here energy is finite, that is its value ranges from 0 to infinity, whereas power is equal to 0. The signal energy of a signal is defined as the area under the square of the magnitude of the signal, that is Ex is equal to integral minus infinity modulus of x of t the whole square into dt. The unit of signal energy depends on the unit of the signal. Power signal, it is nothing but some signals have infinite signal energy. In that case, it is more convenient to deal with average signal power. For power signals, the range of power from 0 to infinity, whereas energy is equal to infinity. Average power of the signal Px is equal to limit t tends to infinity 1 by t integral of minus t by 2 to plus t by 2 modulus of x of t the whole square dt. For a periodic signal x of t, the average power signal Px is equal to 1 by t integral of t modulus of x of t the whole square dt. T is the period which we choose for a signal. Periodic signals are generally power signals. A discrete time signal with finite energy and zero power is called energy signal. That is, energy will be infinity and power is equal to 0. And similarly, here also Ex is equal to summation n is equal to minus infinity modulus of x of n the whole square. And Px is equal to power is equal to limit n tends to infinity 1 by 2n summation n is equal to minus into n modulus of x of n the whole square, which is nothing but for periodic signal it is Px is equal to 1 by n summation n is equal to n modulus of x of n the whole square. So based on this, the important questions like continuous discrete time signal, energy, power signals, periodic, non-periodic signals, their conditions need to be satisfied can be asked. And also problems from this unit plays a major role in 13 marks, 15 marks as well as in 2 marks also. So moving to the important website reference are also given, and book reference corresponds to Dr. J.S. Chittor. Page number 14 to 51 of chapter 1 corresponds to the topic which we have discussed now. Hope you all have learned about the classification of signals and their operations too. Mainly all these implementations in real time applications like mobile communication, signal processing areas, medical communication, everything comes under the signals and systems. So every signal, for example, if you are measuring an ECG heart rate, it is also a signal, so it needs to be converted to a form which is understandable by the machine and which process the output, whether the patient is in normal condition or abnormal. So everything comes based on this signals and systems only. This is about the topic of content which we have discussed now. If you have any doubts in this, you can ask me and get the details. Thank you.